Hi everybody and welcome. Today's 1.4 support video is going to help you out with one of each type of example. So we'll take a look at using algebra, we'll take a look at looking at a graph, and we'll also take a look at looking at a table to see if a function is either even, odd, or neither. And to incentivize you to use these support videos today, you'll get 3 free answers if you're following along. Yay! So the first one will actually do literally the first question. So here we have f of x equals x cubed plus x. You're allowed to plug in any numbers that you want. I like the number 2 because I think it's pretty easy, but like I said, any numbers that you want. So let's mix it up. We'll try 3 this time. So you always want to plug in exactly the number, so 3, and then you also want to plug in the counterexample, the negative version of that number, so negative 3. So for our first one, we'll do 3 to the third power plus x, which again is 3. And then for the second one, it's negative 3 to the third power, and then plus negative x, which in this case is negative 3. So taking a look through here, 3 to the third power is 27, plus 3 gets us an answer of 30. Negative 3 to the third power this time is going to get us an answer of negative 27, plus negative 3, which actually does get us an answer of negative 30. So same number, different signs. Hooray, we have an odd function. So that's number 1. Take a look at another type of question here. Number 4, if we're taking a look at a graph. So on this graph, basically what we see over our axis, and I'll draw this as best as I can. I'll draw just a portion of it. So that's basically how this one starts, and it does keep going from there, but the idea is everything directly crossing through the origin? So let's pick 2 points to start off with. So if we pick this point right here, where I think this is where like x is about 2, and then this point right here where x is approximately negative 2. It's not exactly that, but somewhere in that range. What we should be able to do is connect the dots directly through the origin. So if I rotate this perfectly, and if I've drawn this well, we should see directly through the center of these dots, right through the origin. And again, like I said, if I drew this better, this is on a line. So what that's going to tell us is, graphically looking through that, because it crosses through the origin, if we go back to our definition, this is going to tell us that we, again, have an odd function. Another one that we could do is take a look at a different point here. Maybe we can use this point here and this point here. To connect the 2 dots, we should go right through the origin. So if we're looking at our ruler, connecting the dots, it goes right through the origin. The same thing should work here if we went to like this point at like 3, somewhere in this range, and negative 3. So 3 and negative 3 should, again, if we look straight through them, connect the dots going directly through the origin. So let's do that. See if I can grab the ruler. And again, connecting the dots, our ruler goes directly through the origin. So that's what that means. Symmetry through the origin is if you connect the 2 dots from the positive and negative value, your ruler should directly touch the origin. So that is how we prove a function is odd on a graph. Our last example here, number 7. So this is a little bit of a tricky one, but the way that I like to do it is just line up the values next to each other. So if we have negative 4 is negative 128, and right next to it we can write down 4, which is positive 128. Keep going, just double check. Negative 5 is negative 250, and positive 5 is positive 250. And then finally, negative 6 is negative 432, and positive 6 is positive 432. So hey, what do you know? Same numbers, different signs. So it looks like 3 in a row, we are looking at some odd functions. So again, from here to here, 128 and 128 are the same, but they have a different sign. Same here with 250, same number, different sign. 432, same number, different sign. And remember, when we're doing this, we are specifically looking at our y values. So we're trying to see, are the y values the same number with different signs? So they are, because of that, that is the exact definition of an odd function. All right, you can probably guess that the other answers are going to be different than odd every single time, but here is an example of how you do it for a chart, how you do it for a graph, and how you do it algebraically. As always, thanks for watching. Good luck on the practice questions. Call me or done when it's over if you got any.